So this question is about moments and about Hooke's law. First step is to work out what the moment must be at Q. So what force must Q provide to balance the moments? I'm not interested in what's happening at P. So I know that there's a force at P, and I know it's in equilibrium. So I'm going to take moments about P. Because I don't need to find out what the force is at P. So I'm going to take moments about P and then solve to find out what the moment must be at Q. So I've got P here, and I've got my center of mass providing an 18 Newton force, and that is at 0.65 meters from the pivot. And then an additional 0.15 meters from that, I have Q. And I've got the line there, and Q is providing a force upwards, but I don't know the strength of that force upwards. So taking moments about P, the turning effect due to the 18 Newton force must be equal to the turning effect due to Q. So force times distance, so if I call force Q times distance Q, so distance Q is equal to the force due to the weight, so Fw, the distance of the weight, Bw, and then I can substitute in for those values and find what Fq is. So Fq is the force due to the weight is 18. The distance of the weight from the pivot point is 0.65. dq, this is the bit I need to be careful of, is 0.65 plus 0.15 because it's the distance from the pivot point. And then I can calculate that. So 18 times 0.65, calculator on, 18 times 0.65 divided by 0.65 plus 0.15. And I get 14.6 newtons. The force required to balance the moment at Q is 14.6 newtons. Now, the next step is to work out what extension is required. So the force is the spring constant multiplied by the extension. I'm asked for the extension. So we've got the force is 14.6, and to solve for the extension is F over K. The F is 14.6. The K was 240, if I remember correctly, at 240. So now I do 14.625, which I've left in my calculator, divided by 240, and I get 0.0609, so 0.061 meters, which is about 6 centimeters, and that is one of the answers.